Hi there. Thanks for joining us. My name is Andrew Dunkley. This is Space Nuts, where we talk astronomy and space science. And coming up on today's program, SpaceX in the news. You could say for all the wrong reasons, but that's debatable depending on which part of this story that you're talking about. But they've hit the moon, not in a good way. We'll also be looking at the upcoming launch of the Nancy Grace Roman Observatory. We've received a lot of questions from the audience about that in recent times, and with good reason. It's a very exciting mission indeed. And if time allows us, we'll look into a new study about Neptune's moons. Stick with us. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to furnish us with all his knowledge, which will only take a couple of minutes. No, it's not. It'll take probably a lot longer than that, is Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Jonti, hello.
Good afternoon. How are you going?
Good. You should feel good too, because it's only when I get to like people that I insult them like that.
It's fine. It's just like growing up in Yorkshire again. It seems to be a recurring theme with kind of the better parts of the world, is that the more you get on with people, the more offensively you criticise them. And, it's that whole thing of the inverse of that being that the less you like people, the more polite you get, which reminds me of Pratchett's almost version of the Montagues and Capulets with the old warring aristocracy who'd now got to such a level of dissatisfaction with one another that the only polite forms of conversation were about the weather, and that was it. So they'd have these meetings at formal events. It's like, oh, the weather today is beautiful, isn't it? Well, So, yes.
Yes, but you're not.
Yes.
Yeah, that kind of thing. We've got a lot to get through and very little time to do it, but we will manage as best we can. And this first story is a bit of a combo, two lunar-based stories. And depending on where you sit on the spectrum of should we or should we not, they could both be considered bad, or one could be sort of considered good, depending on, perspective. But it's involving SpaceX and the recent collision, if you want to call it that, between a SpaceX rocket body and the lunar surface, which happened not so long ago.
Absolutely. I mean, as we're recording this, it was very, very recent.
Very recent.
By the time you're listening to this, it's slightly in the future. And for that reason, we didn't talk about this last time, because last time we were recording in advance of this happening, but the broadcast would have gone out after it happened, which would have been very bizarre. Now, we're recording after the event and you're hearing it after the event, so at least the time flow is in an appropriate order. The story here is basically one of celestial littering, which is a recurring theme. We've got this ongoing discussion in the past of what goes up must come down.
Yeah.
And the ongoing issue with the commercialization of space leading to a lot of things being launched, and the vast majority of those things that are launched return to Earth in a fiery blaze of glory. We see space junk more and more often in our skies. But on Earth, the concerns are primarily about the atmosphere with the stuff coming back in. We've talked a lot in the past about the worries atmospheric scientists have about dumping all these metals into the upper atmosphere and what it'll mean. But very rarely do pieces of space junk make it to the Earth's surface. And that's because we've got an atmosphere. The atmosphere is brilliant and protects the surface of the Earth from all but the biggest bits of space junk making it down to Earth.
Yep.
Despite that, there is enough concern that people are doing things like calculating the odds for insurance companies of how likely it is that someone on Earth will die due to space junk in the next decade. Things like this. So it's not a null concern for people on the surface of Earth, but the odds of something crashing into Earth's surface that is something we put up into orbit are usually fairly low, because most of it goes away in the atmosphere. Ablaze. It doesn't burn up. I'm always cautious of using the phrasing burn up, because that evokes fire, and fire requires oxygen and it's a chemical reaction. This is ablation, because the air gets superheated and bakes away the material. But effectively, colloquially, you'd say this all burns up. The Earth, though, isn't the only thing out there that's in the firing line. And this is where this story comes in. So a while back, SpaceX launched a couple of things to head to the moon. And in order to do that, they had to boost their rocket to a higher speed than they normally would do, which meant that the upper stage of this rocket went onto a very elongated orbit around the Earth, and then essentially goes into free fall. It has burned all its fuel. It is, to all intents and purposes, out of control. And that means its orbit just evolves under the gravity of the Earth and the Moon and the vagaries of the environment around the Earth. Fast forward to now, and that out-of-control rocket body crashed into the Moon. Now, the final collision was predicted in advance. This was big news for at least a week beforehand. And it was estimated roughly where the thing would hit the Moon. Now, you're talking here about a fairly hefty chunk of material. You're talking about, a couple of thousand kilos, if not more, a fairly big chunk of material, crashing into the Moon's surface at a speed of a few kilometers per second. And so the predictions were that when this hit, in the location it hit, it would dig out a crater maybe 20-25 meters across and kick a load of dust and material up. It would create a plume that would rise above the Moon's limb, probably rise as high as 100 kilometers or so, and slowly fall back to the surface of the Moon. The time at which the impact was going to happen was predicted, so astronomers on the part of the Earth that could see the Moon were watching to see what happened. Although, to be fair, it was predicted that for most people you would see absolutely nothing. So this thing was going to hit on the daylight side of the Moon, and so reflected sunlight would obscure pretty much everything. So people looked, didn't really see anything. The only really, I think, strong indication that something was seen from the ground were a group of people observing from the Lowell Observatory in the US who were looking specifically at very specific wavelengths of light for sodium ions and lithium ions. And they saw what appeared to be an impact plume at the right location at the right time, kind of confirming that the impact happened.
Yeah.
Then, after the event, the first images came back of the site that was hit, and those images came back from a Korean spacecraft, South Korea's first ever lunar spacecraft that was launched back in 2022, actually in August 2022, has been floating around minding its own business, doing work, and pretty much widely being forgotten. I don't remember ever talking about this spacecraft before, even though it's a great, even though it's a great achievement that the Koreans got it into lunar orbit and have been doing great stuff with it.
Yeah.
But this spacecraft, Danuri, flew repeatedly over the area where the impact was going to happen. And the Korean Aerospace Research Institute, KARI, released an announcement that said, and I'm quoting here, Danuri began observations about 30 minutes before the collision and through orbit control passed over the impact site multiple times, conducting a total of 8 imaging sessions. Through this observation, changes in the terrain around the impact site and traces of ejector spread were confirmed. The spacecraft secured both pre-collision and immediate post-collision footage, enabling analysis of the changes that have happened. So there are now images. Only looks like a little black smudge, but to be fair, this is an area maybe 20 or 25 meters across. It's pretty impressive that we can get images that resolve that impact feature on the surface of the Moon. And I think that in itself is going to be pretty important for researchers studying how craters form, how the lunar impact kind of scenarios happen. When you're hitting an object with the regolith like the Moon, without an atmosphere to protect it, all this kind of stuff's pretty important, but it's doubly important in the context of our future use of the Moon. NASA have got these plans to put astronauts in a permanent lunar base at the South Pole. I know China have expressed similar aspirations.
Yeah.
Elon Musk is looking at building a lunar industry, which we'll come to in a minute.
Yeah.
If you're wanting to have permanent presence on the Moon, and particularly permanent human presence, you need to have a fairly good understanding of what's going to happen when impacts happen. You would have also thought, though, that you would like to prevent impacts from happening, particularly impacts from things that are out of control. Because if this thing had come into the Earth's atmosphere, pretty much all of it would have ablated. You wouldn't have had to worry on the ground. On the Moon, though, it makes it to the surface intact. That size of that impact scar, 25-27 meters across, sounds to me very much like the size of a lunar habitat that you'd build. Mm-hmm. And the last thing I would want is to send astronauts up to the Moon and then have a bit of a discarded rocket crash in and wipe out the habitat and kill them. That doesn't sound like a good idea. Not just that, it's raised concerns not only about our kind of future presence on the moon, but about the preservation of our archaeological sites on the moon. We've talked about the incredible work of Professor Alice Gorman in Adelaide, who talks about space archaeology and has been trying to raise awareness of the cultural impact of places like the Apollo 11 landing site, where we've got this pristine record of humanity's first steps on the moon. And it'd be tragic if something like this happened and crashed into that.
Yeah.
It's really caused a lot of discussion about what's going on, what we should do about it. And I don't know that it's a particularly good look for SpaceX that this has happened, but it should be stressed that they are far from alone. I saw listed on a BBC article at the time of the impact detailed some of the other things that have hit the moon. And they reckon that more than 3,000 human-made objects have now either landed on or impacted the moon.
Really? 3,000?
3,000 or more.
I would never have guessed that many.
It's astonishing. And that's a total of more than 190 tons of material. Now, some of that landed softly. You know, we talked about Apollo 11, for example, the lunar landers from many nations. Many nations have now landed on the moon. We've got crash landings like the Israeli mission that spattered tardigrades across the moon because they could, which still strikes me as one of the dumbest space missions ever carried out. You know, from an astrobiology point of view, we want to go to places and look for evidence of life. The last thing you want to do is smear it over the face of the moon. Hey, look, we've put life there. Anyway, that's an entirely other topic. But there's this long history of things hitting the moon in a both controlled and uncontrolled fashion. And it's going to happen more and more the more we put stuff out there.
Yep.
So it's caused a lot of discussion. It is really, really interesting, but it does shine a light on the risk for future missions more than anything else.
Yeah, it does. Notwithstanding that there is an international law in place that you're responsible for cleaning up your own mess. But when things get out of control or fly off in directions that make them irretrievable, what can you do about it?
Absolutely. And I would be very interested to see whether any applications of that law apply to things beyond the Earth's atmosphere, because that gets enforced when you look at people cleaning up things on Earth. So there was a story a few years ago about some SpaceX rocket parts in the Snowy Mountains in Australia.
Right. Yeah.
And SpaceX, in theory, had to come and collect them, and there was a little bit of a lag in that happening. Similarly, when there was a fragmentation of one of their big Starship test launchers that dropped debris around the Caribbean, there was a lot of controversy about whether they were actually bothering to collect stuff or not.
There is a faster way. It's called eBay.
Oh, absolutely. This is kind of an ongoing thing, and I'm not sure that, once again, legislation has kept up with our use. We were talking about this last week with satellites, I think, and with the FAA and FCC approving things, but making it very clear that they weren't there to judge on whether the use of space was sensible. They were just ruling on their small area of influence and abrogating other responsibility. I don't think we have yet any real global pathway to improving things and getting a better handle on what we should and shouldn't do. But the discussions are happening, and every time something like this comes along, it further prompts those discussions and raises awareness of the problem, I guess.
Yes, and once people are up there in a permanent or semi-permanent situation, that's when you really got to start thinking about these kinds of problems. Hitting the moon at the moment is it is a risk for existing infrastructure and historical sites, but the day will come where people are there, and that creates a whole new ballgame. So, yes.
And industry will be there, which brings us to the second half of this story.
Well, let's get into that, because this also involves SpaceX, and Elon's big plan is to put a manufacturing plant on the moon to build his StarMind AI satellite array. And it looks like that this will be a fully automated system. They'll manufacture these things and launch them from the moon. And we're talking like, I don't know, is it 1 million of these things?
That's what he wants to do.
Yeah, this is the stuff of science fiction, but it's rapidly becoming something real, isn't it?
It is. And we've discussed the light pollution side of this repeatedly on the show, both myself and Fred. This StarMind idea is the idea that they will launch essentially data centers and AI centers into Earth orbit to farm solar energy. And you'll have these heavily computing-based satellites with enormous solar panels, probably at a relatively high altitude above the Earth so that they can get permanent sunshine, which I know a number of reports over the last few months since this has been talked about have spoken about how this will give a visible ring in the night sky that'll be visible all night from all locations on the Earth, and it'll be like living with a narrow, very thin ring, a bit like Saturn's rings, but just a single ring rather than a really broad one.
Yeah.
Lots of concern, lots of speculation about that. This story relates to one of the quarterly calls that SpaceX are having. This is apparently the first ever, but they're going to happen every quarter. And it's probably something that's followed on from the listing of SpaceX on the stock exchange and that, where Musk talks to the investors. And this call was on the 4th of August, just under a week ago for me, but by the time you hear this, 3 weeks ago. And in that call, Musk talked widely about his dreams to put factories on the moon. This is something he's talked about before, so it's not utterly new, but he's given more detail of what they want. He talks about landing a huge amount of tonnage on the moon to build factories. The factories will use robots akin to the Optimus robots that they use in the Tesla car manufacturers, I think. And he's already talking about sending some of those Optimus robots to Mars. He wants to use the moon to build these star-mined AI satellites, which he'll then launch with giant railguns using the abundant solar power you can generate on the moon, building a really, really, really long track with a kink at the end where you can accelerate using magnets, something to launch speed. And this is, again, something that's featured heavily in science fiction over the years as a method for launching things from bodies without an atmosphere.
Yeah.
All makes sense. But the idea he's got is that by going onto the moon, he can scale up manufacturing to get to being a factor of 1,000 and a factor of 1,000,000 times more industry than he has on Earth. So a huge, vast expansion in their building capacity. And it's a kind of thing that many people might poo-poo, but I think if we were talking a decade ago, people would have been poo-pooing the idea of Starlink.
Yep.
And he's been very successful getting that off the ground and up and running. So I wouldn't rule this out. And long term, we are seeing the dawn of the commercial use of space, and the commercial exploitation of the moon and asteroids is sure to follow. So it wouldn't surprise me if other companies are having similar ideas, and it may be that SpaceX are the first, but not the only ones to do this, if it happens. What I found interesting about this is this story's going round at exactly the same time that we're talking about the uncontrolled crash of the SpaceX rocket to the moon.
Yeah.
Which means you've got this almost a conflict of interest for SpaceX here, because on the one hand, they want to be able to launch their rockets. They've got to get that tonnage into space, as Musk says. And if they're launching things to the moon, that'll leave a lot of rocket bodies on orbits that could eventually impact the moon. And they're out of control. Yet at the same time, he's looking at building capacity for manufacturing on the surface of the moon. Now, that strikes me that on the one hand, he's increasing the risk that his industry will be damaged by his own industry, if that makes sense.
Oh, yeah.
There's always a possibility that one of his rockets will crash into one of his factories. So it may well be that leads to a certain amount of self-interest in looking at ways to manage it that the outcry of astronomers wouldn't. You know, it's a lot more impelling for a company like SpaceX to want to find a solution to a problem that will directly impact them than a problem that's just upsetting a few people and is considered a little niche. So it's going to be really interesting to see how these two things kind of develop in parallel, I think.
Yeah, Elon Musk is, to some, a visionary, to others, an absolute nutter. But when you look at what he's achieved, you can't deny it. And when he starts to talk about doing things like this, you can't say it won't happen. Because he's proven that he'll put his money where his mouth is over and over again.
Yeah, and I do try when I'm talking about this. I know I fail sometimes, but I try to be as even-handed as I can be, because I think very few people are purely good or purely evil. There's good and bad to most people, and there are good and bad to the things that people do. And when we've talked a lot about Starlink, I always want to be at pains to stress that there is real benefit comes from this as well, because I think a big mistake people make is only focusing on the negative. And that doesn't put you in a good position. You need to look not to stop things entirely, but to look for a position where you get the maximum benefit for the minimum cost, you know, that sweet spot.
Yeah.
And it is undeniable that Starlink has brought with it great benefits to people in terms of being able to access the internet and access communication where previously they weren't able to because they were too remote. It's also come with associated problems. And I think this kind of endeavor is going to be the same. It's also probably very fair to say that commercial use of the moon and commercial use of other things in the solar system is going to happen whether SpaceX do it or not, but they're very much at the forefront. So I don't see an argument to be made for just saying, oh, well, they should stop this and think about it. I think what's really important is all this stuff is discussed very publicly and we figure out what humanity as a whole thinks is the right balance to have. And that's challenging. I mean, it's not a case of nothing and it's not a case of everything, but it's probably going to be the case that the use of the moon is just like the use of low Earth orbit, where the commercial use rapidly outstrips our abilities, at least at first, to legislate around it, and then the legislation will come afterwards. In much the same way we were talking last week about previous examples being things like the internet or even the printing press. Things like this, the use always outstrips the legislation, then the legislation sprints to catch up.
Yes. Well, it crawls in some cases, but I know what you mean. And look, if SpaceX don't do this, as you said, someone else will. It's, everyone can point the finger at Elon Musk and SpaceX and say, oh, naughty. But if they say, look, yeah, okay, we agree, it's a bad idea, we won't do it, someone else will.
Absolutely.
Most certainly. So it's probably more a case of finding a way to manage this properly into the future rather than just saying, no, it shouldn't happen, shouldn't be done, no way, no how, because it will happen regardless.
Yes.
Interesting times ahead. A couple of interesting stories focused on the moon. And if you want to read about that impact, you can do that at the space.com website. I knew I'd find it there somewhere. This is Space Nuts with Andrew Dunkley and Professor Jonti Horner.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Space Nuts.
Now to something very exciting. We've been building up to this for quite some time, and as this podcast goes out, the day of release for this one is the 27th of August. We are 3 days away from the launch of the Nancy Grace Roman Observatory. That is big-time excitement.
It is. Of course, the caveat is that in the couple of weeks between recording this and it going live,
it could be delayed.
Change. It's like the trains in the UK, never trust that they're going to arrive until they actually have done, and even then be sceptical.
Yeah.
It's that kind of thing. But in this case, that would be quite startling because until very recently, everybody was expecting this telescope to be launched next year. So the launch, if it goes ahead on the 30th of August, will be a launch that is 9 months ahead of schedule, which is very, very cool. Now, the scheduled launch time at the time of recording will be the 30th of August at 9:26 p.m. Australian Eastern Standard Time, which is 11:26 a.m. Universal Time or Greenwich Mean Time.
Yeah.
I think a lot of these launches get streamed online, so for those of you who are keen, there will almost certainly be live coverage of that, and a lot of very nervous people watching the launch hoping that it doesn't turn into a firework, which has happened before.
It has. We don't want to think about that. We're talking $4 billion worth of hardware.
We are, but I mean, this is why there are insurance policies, right? It's there is a risk.
I'm surprised you'd find an insurance company willing.
I think it's become fairly big business, actually. I mean, it's not my area of expertise, but I remember when we went to meetings a few years ago about off-Earth resource collection, there was discussion about insurance and stuff like that. And apparently there are insurance underwriters who insure satellites and launches. And I seem to remember, although I stand to be corrected on this, that the cluster mission, probably 15, 20 years ago now, blew up on the launch pad and insurance allowed them to essentially rebuild it and launch it again. So it does happen, but fingers crossed, touch wood, there will be no problems with this. And what will happen is that on the 30th of August, a rocket will take off, SpaceX rocket, that will carry Nancy Grace Roman telescope into Earth orbit and beyond, will boost, hard, just like happened with the James Webb Space Telescope, to give it a good kick, because this thing is destined to go out to join James Webb at the outer Lagrange point, beyond the Earth, so about 1 million kilometers further from the sun than the Earth is, but moving in lockstep with our planet, at this kind of gravitational sweet spot where you can hang around fairly safely for a long time. To do that, it is loaded with what is described as a very toxic fuel, hydrazine. They want to move away from it, but until they find a better alternative, they haven't yet. So as we talk right now, the spacecraft has been fully fueled, which is why they're fairly confident that they'll launch on time. That amount of fuel sets the lifetime of the mission, and there were similar discussions with James Webb when it launched a few years ago, in that the nominal mission is 5 years. So once Nancy Grace Roman gets to the L2 point, and that journey will take about 100 days from the launch, it is scheduled to have around a 5-year mission.
Yeah.
It may have a longer mission than that if it manages to keep hold of its hydrazine fuel. So what happened with James Webb was that everybody was delighted with how accurately and beautifully it launched. So it needed to use less fuel to get on station, which meant that it should have more fuel for a longer life. And therefore, the projected mission went from 5 years to maybe 10 or 20, because it managed to keep those stocks of fuel. And hopefully, fingers crossed, touch wood again, the same will be true for Nancy Grace Roman Telescope. People have been really looking forward to this. Now, the first I remember of Nancy Grace Roman Telescope was when it used to be badged as WFIRST, a Wide Field Infrared Survey Telescope. That was kind of the first proposal, and that was going back to 2011, 2012. And shortly after those first proposals, there was a really interesting story came out that NASA had been told that there were suddenly a number of what are known as National Reconnaissance Office telescopes made by the Harris Corporation. The NRO offered to donate 2 telescopes to NASA, which are telescopes comparable in size to the Hubble Space Telescope, but a wider field of view. To put that in other language, effectively the defense community in the US said, by the way, we've got a couple of spy satellites that we're not going to use, so do you want them to actually do science? Which meant, at least to me, for the first time I became aware of the fact that there were a number of Hubble-class telescopes orbiting the Earth looking down. I hadn't quite realized spy satellites had got that big and that impressive. But anyway, that was a really nice mechanism through which, you could do a cool mission a little bit cheaper. That got a bit of political interest and all the rest of it. But over time since, the telescope was planned and then approved and then built. Now, I must confess that I don't actually know whether the current iteration of Nancy Grace Roman is a former spy satellite or whether they moved away from that. But what it is going to be is a space telescope with a mirror 2.4 meters across, which is your Hubble Space Telescope size, wider field of view than Hubble, that will observe in the optical and in the near infrared using 2 instruments. So it's going to have a very wonderful wide field camera. This is a camera with 300 megapixels. Yeah. So that's a hell of a lot better than the CCD camera I've got on my digital telescope here, Fabulous camera that will work at both visible and near infrared, will be able to take images in a wide variety of color bands and things like this. So that's going to be a fabulous camera that allows survey work to be done. And a lot of the work that is planned for this incredible telescope will be looking at the kind of cosmology stuff that you get so many questions about, dark energy and gravitational lensing and things like this, stuff that's a bit outside my professional wheelhouse. But it's also going to be carrying out an incredible survey looking for exoplanets. It's going to stare at the bulge of the Milky Way galaxy, looking for gravitational microlensing events, which is when a planet going around a star where we can see neither the star nor the planet passes between us and a more distant star, and some of the light from that star is bent and focused towards us, causing the star to brighten and then fade. That microlensing event lets us detect the object that we can't see passing by in between. And it will also let us find free-floating planets. So Nancy Grace Roman Telescope's going to do a fabulous kind of census-type survey of planets towards the middle of our galaxy using this microlensing technique. It's also carrying its other instrument, which is a really high-contrast camera with a very small field of view, very different, that is attached to a coronagraph. And a coronagraph is a fabulous device that allows you to block out the light from a light source, like a star, and allow you to look at things that are very near to that light source that would normally be lost in the glare. And this is planned to take advantage of the fact that this thing's in space, we don't have the Earth's atmosphere to deal with, to use both a camera and a spectrograph that are connected to this coronagraph to look at exoplanets and actually try and get direct imaging observations of them and to learn more about their atmospheres. It'll be used for planets more like the size of Jupiter than the Earth, but it's going to be an incredible tool for learning more about planets around stars like the Sun, effectively.
Yeah, it's going to be very exciting and can't wait. Hopefully everything will run according to plan on August 30, which by the time this podcast is released will be 3 days away. And we wait with bated breath. It's only got to go 1 million kilometres to get where it's going, which will take, it's not a heck of a long trip, but it's going to take them a little while to get there. I can't remember how long it was now.
Oh, well, it's 100 days to roll on out to the Lagrange point for a start, and then there'll be time to get yourself fired up and get all the testing done and all the rest of it. But it's going to be a fabulous tool, and I know myself, my research is mainly theoretical. I'm mainly working on computers. And to be honest, I'm at a stage in my career, and I'm sure Fred can empathise with this, where I'm becoming more of an administrator and a supervisor than I am a researcher. But I know colleagues of mine at UniSQ have been very successful in getting time to use the James Webb Space Telescope to study exoplanet atmospheres. And I'm thinking here particularly of George Zhao and Chelsea Huang, who are really, truly world-class scientists. And I think they are waiting with bated breath to see what we'll be able to do with this. So yes, you'll get a lot of discoveries coming out from the US, but we will have Australian involvement looking at this and getting amazing results right here in Australia. And for people living in other countries will have their own scientists beavering away using Nancy Grace Roman Telescope to do amazing, amazing things.
Indeed. And we will obviously let you know how it all goes once we know whether or not it launched on time, whether or not anything, fingers crossed, happened to slow it down, whatever. Hopefully not. It should all go according to plan. One hopes. Anyway, we'll watch with interest, and you can read that story also on space.com, but there are plenty of platforms carrying the story of the Nancy Grace Roman Observatory, and if all goes to plan, there'll be many, many more stories in a few days' time. This is Space Nuts, and you're with Andrew Dunkley and Professor Jonti Horner.
3, 2, 1.
Space Nuts.
And seeing we've got a few minutes up our sleeve, we'll go on to our third and final story. And this one involves 3 moons of Neptune, which they think, according to a new study, might have been created in a rather Earth-shattering or Neptune-shattering way involving the moon Triton, which is also a very mysterious place in our solar system.
Yeah, and this is a fascinating one. Now, some of the coverage of this has been kind of presenting this as a new theory that's come up from the observations. And to me, it's actually a bit the other way around, where these are observations that are potentially supporting ideas that have been held for a fair while. Now, Neptune has a system of satellites like the other giant planets and the ice giant Uranus. But Neptune's is unusual. You've got a real behemoth of a moon in the form of Triton that, along with our moon, is one of the 2 oddest moons of any planet in the solar system. To give a bit of context from that and take a step back, aside from our moon and Triton, all of the other hundreds of moons in the solar system fall into 2 real categories. You've got regular satellites, which fall on orbits that are above the equators of their planets, are very close in, and they're going around on circular orbits that are in the same direction as the planets spin. And they're thought to have formed, particularly around the gas giant planets, but also around Uranus and Neptune, in much the same way that the planets formed around the sun, in that you had a disk of material around the planet and moons formed in that disk. They're quite compact and close in. You've then got irregular satellites, which are much, much, much further from their planets, are found around the outer planets, are moving on a wide range of very elongated, often retrograde orbits. And these are thought to be captured objects that have then been smashed into pieces, giving you families of satellites. And it's these that give Jupiter and Saturn in particular such incredible numbers of satellites, more than 100 for Jupiter, more than 200 for Saturn currently known. Triton and our moon stand out as oddities because they don't quite fit either class. And for Earth's satellite, the moon, the origin of the moon seems to have been a giant impact, very different to either scenario for the regular or irregular satellites. But Triton around Neptune is really kind of weird. It's a moon that is 2,700 kilometers in diameter. It's a chunky boy. It is close enough in that it would normally be considered one of the regular satellites. And it is orbiting pretty much above Neptune's equator, but it's going around the wrong way. It's moving on a retrograde orbit. When all of the other moons in the inner part of the Neptune system are going around on a prograde orbit. So there is no real possibility that Triton could have formed where it is today. And that's led for many decades people to speculate as to the origin of Triton. And typically the two main ideas are either that it was formed by a trans-Neptunian object or an object like Pluto coming into the Neptune system, colliding with the moon, knocking that moon out of orbit, and Triton being captured by the exchange of angular momentum. That's not really the favoured idea, though. The favoured idea is that you had a binary object, a bit like Pluto and Charon, or many of the trans-Neptunian objects are these quite wide binaries of objects with similar sizes. You had one of these objects in the early days of the solar system, came very close to Neptune, and you had this three-body encounter where you've got Triton and its companion, which was possibly another object the size of Pluto, bound together, coming so close to Neptune that Neptune tore the couple apart. As it tore them apart, Triton was moving around its shared centre of mass with its partner at such a speed that it was moving slower than the escape velocity of Neptune. So one component of the binary was flung out and the other was captured. And that's a way to slow something down enough that it can be captured. So you trap Triton into this orbit that is retrograde, going around the wrong way around, that quickly damps down to become circular because of tidal effects with Neptune. Now, that seems to be the story of Triton, and what supports this is that the regular satellites of Neptune are pretty small and insignificant, and smaller and more insignificant than the similar satellite systems of the other planets. They seem to be a bit smaller and more weedy than you'd expect them to be.
Yeah.
So the idea is that the capture of a moon the size of Triton would be pretty dramatic and would destabilize the Neptune system. The moon outside Triton, Nereid, which was the second moon to be found around Neptune, is a really interesting one because it's a fair bit further out than Triton, but it's moving on this really elongated prograde orbit. And it's thought that that may well have been initially a regular satellite that was destabilized by Triton and flung onto this longer orbit. It's not really considered an irregular moon, even though it behaves a bit like one. It's really close in. But the moon's closer to Neptune than Triton, of which there are 7 known. We've got Naiad, Thalassa, Despina, Galatea, Larissa, Hippocamp, and Proteus. They're all relatively small. Proteus is the biggest at 420 Ks. The rest are not quite as big. And the only images we've got up close and personal come from the Voyager 2 spacecraft in 1989 that show these moons to be a little bit irregular, and they're also a little bit more stirred up and agitated in orbital tilts and orbital eccentricities than you'd expect them to be. I mean, they're barely tilted and they're barely on non-circular orbits, but you'd expect them, if they were properly original regulars, to be totally circular. So the idea is maybe Triton stirred them up. Now, one of the suggestions to explain why they're all so small is that Triton, as it was captured and then as it's migrated since, has stirred them up enough that the original moons were destroyed. It stirred them onto orbits that collided with each other. That formed a new disk of material. Some was lost, but new moons were born of the process. And that's become kind of like the canonical understanding of what we think happened to Neptune's moons in the early days. And that all, a lot of background, brings us to the new observations. As I say, the observations we had before came from Voyager 2. That's the up-close and personal we've got. But there's been some new work done using the James Webb Space Telescope to get data on 3 of these moons, Larissa and Galatea, been two of them. And I think the third one was possibly the next one out, Proteus. Have to double check that, but I think it was. And what they found, though, was when they looked at both Larissa and Galatea, they found clear signals of clay-type minerals on the surfaces of these moons. Now, that's really unexpected. Clay minerals form at temperatures high enough for you to have liquid water, because clays are formed in the presence of liquid water.
Yeah.
And the surfaces of moons in Neptune's orbit are blooming cold. They're like 180, 200 degrees below freezing, which is not where you'd expect to find liquid water. So what the authors are proposing is that the surfaces of these moons, which look, to be honest, more like the surfaces of asteroids in the asteroid belt, are actually made from material that was once deep in the interior of moons that formed before, that therefore got hot enough for liquid water to be present. And we've talked a lot before about other moons in the solar system that have subsurface oceans. So you have these first generation of moons with their subsurface oceans, water present, high enough temperatures for you to develop all these clay minerals. Then those moons get stirred up when Triton is captured. There are collisions, they're smashed apart, and you create a disk of material around Neptune that contains the material from the old moons, clays and all. Then you form new moons, and some of those new moons have that clay material on their surface. So what's been argued essentially is that this detection of clays in the last place you'd expect to find them is like the smoking gun. It's a clue that is telling us about the heritage of this system, about events that happened more than 4 billion years ago. And it's telling us about this kind of collisional history and the dramatic story of the Neptune satellite system. I think it's an astonishingly cool result. And it's really cool for me as someone who's read about Triton a lot in the past, thought about it a lot, that the ideas that were being put around even when I was a teenager and listening to talks at my local astronomy society about the disruption of the Neptune satellite system are suddenly finding a test thanks to people using James Webb. So theory making a prediction, that prediction getting more support. I think this is really lovely.
Yeah, it is. And it certainly shows the worth of James Webb. And, very soon, the Nancy Grace Roman Observatory, we're going to learn more and more about some of those not so deep mysteries. There, in the scheme of things, it's not far away, Neptune, but it's far enough away to still be mysterious in many ways. We really need to send a mission out there again soon, don't we?
I was just thinking that there's been a lot of talk over the last decade or so, really, with solar system astronomers getting more and more enthusiastic about the idea of sending new spacecraft out to Uranus and Neptune. There's always debate when it's time to pitch new missions for NASA of the different scales, people putting competing proposals. And I know at the last round, there were a number of proposals of missions to Venus, because we've not been there for a long time in terms of the Americans haven't been. I know Japan had a fabulous orbiter doing some great work there. There were also some really strong proposals of missions to Uranus and Neptune. I think this was the kind of medium-sized stuff. So not Nancy Grace Roman pots of money, but more the $400 million rather than $4 billion price missions. And in the last round, I think the Venus missions won. But there is this growing longing to get missions to go back there and actually have orbiters, because both Uranus and Neptune, the only up close and personal we've had with them were the Voyager spacecraft that launched in 1979, launched back when I was 1 year old.
Yeah.
And flew past Uranus and Neptune. It was only Voyager 2 that got there. Voyager 1 went off on a different journey. So we've had one spacecraft that flew past faster than a speeding bullet, that spent less than a day within good imaging distance of these planets, returned really tantalizing information, and then departed. And we've seen how much we learned from Galileo at Jupiter, from Cassini at Saturn, from Juno at Jupiter. So there's this growing body of scientists who are desperate to see this happen. It won't be cheap. And the other thing is, if such a mission was approved like next week, probably wouldn't launch for the best part of a decade. And it would take the best part of a decade to get there. Yeah. So it's the kind of thing where we're talking now, and I'll probably be retired when these spacecraft get there.
I don't want to think about it. I don't think I'll be beyond retired. Let's just say that.
The sooner the better that we get there then.
Yes, indeed. Great story. You can read about it online. Plenty of platforms have got stories about Neptune satellites. You can read the scientific paper in detail at the journal Science Advances. That brings us to the end. Jonti, thank you very much.
That's an absolute pleasure. Thank you for having me.
Always a pleasure. Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Between episodes, don't forget to visit our website for things to see and do. Like you can send us messages or questions through the Ask Me Anything button at the top. It's labelled AMA. You can sign up for the Astronomy Daily feed. Please leave reviews about the podcast wherever you listen to us, and visit the Space Nuts shop while you're there. Father's Day in Australia coming up soon. That's, you might find something good in there. A couple of good books have been released lately you might like to look at. Maybe. And thanks to Hugh in the studio. Couldn't be with us today. He was actually driving over to get to the studio for us today, but then, as was the case with Neptune, he got hit by a Mitsubishi Triton, and that was the end of that. And from me, Andrew Dunkley, he's okay. So he's, he just couldn't make it. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.